Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of applications of integration. And if I talk about the question that is we are taking from this topic, the question tells us that n is greater than or equals to 2, where n basically that is given to us is a natural number and the function's value holds the value of x going from 0 to 1, which belongs to all the real numbers between them. So from 0 till 1, we can have any values. And the function, it is defined to us f of x as. So it is defined as four functions. The first one is n into 1 minus 2 nx. When I take the values of x from 0 till 1 over 2n, the next value of the function is 2n into 2nx minus 1. When I take the values of x from 1 over 2n to 3 over 4n, the next function I have here is 4n, 1 minus nx. This becomes the value of the function when x is from 3 over 4n till 1 over n. And the last value of the function I have here is n over n minus 1, nx minus 1, when I have the values of x from 1 over n to 1. So these are the four functions defined for us, and the question tells us that n is such that the area of the region which is bounded by the curves given to us are x equals 0, x equals 1, y equals 0, and y equals to the function f of x. So n is such that the area is bounded by this four curves, and it's telling us that the area of the region bounded by these four curves that is given to us is 4. The question is asking us to find out the maximum value of the function that is given to us. So we have to figure out that maximum value of the function if that is asked to us. Let's see how to solve the question that is given to us here. Before starting off with this solution for this question, I'd first like to tell you that please do subscribe to my channel and support the channel as well, because it takes lots of efforts in making these videos for you on everyday basis, and it is free for you but also motivates me to put up better content and try to make the solutions as easy as possible so you understand them in a better way. Let's see how to solve this question. So this question that we have taken here is from the previous year of 2023 JEE Advanced. Let's see how to solve this question then. So the question tells me that the value of x goes from 0 to 1. So if I try to plot the curve for this, let's see what I get. So I take the values of x, let's say 0, and let's say somewhere this is 1. And it is basically divided into four parts. So let's divide this entire interval into four parts. So let's say these are my four intervals that I have here. Now let's put 0 as the value of x. So I know at x equals to 0, this is the function that is followed. So if I put it 0 here as the value of x, I put it here 0. So this entire term becomes 0 and becomes 1 minus 0, which is 1. Then 1 is multiplied with n, that gives me the function's value as n. So at x equals to 0, I get the value of the function turning out to become n. And at x equals to 1 over 2n, which is the upper limit of this function, if I put 1 over 2n as the value of x here, this 2n cancels with this 2n, and that gives you answer as 1. So 1 minus 1 becomes 0. That basically multiplied with n gives you 0. So at x equals to 1 over 2n, the value of the function becomes 0. And if I see that function, it is given to us as 1 minus 2nx. The power of x that I have here is 1. Since the power of x is 1, it is basically a linear function. And when it is a linear function, I get this is basically a straight line. So I get this is a straight line. So I understand from this interval of 0 to 1 over 2n, the function is a decreasing function, right? So we understand about this. Let's see the other one. So if I put x as 1 over 2n, which is the lower limit in this value as well. So I get from here x, if I'm taking 1 over 2n, this gets cancelled. You get 1 minus 1 again, which is 0, multiplied with this, which is 0. So at x equals to 2n, your function is continuous because it is still 0. So if I show it by some other color, let's say this is again 0, and at x equals to 3 over 4n. So instead of 1 over 2n, if I now put 3 over 4n, I get 2n into 3 over 4n. That basically, if I see, gives me 6n over 4n. So this cancels. 6 over 4 is 3 over 2 minus 1. So 3 over 2 minus 1 gives me half. Half multiplied with 2n. This 2 and 2 gets cancelled. So you're just left with n. So I understand for the upper limit, that is basically 3 over 4n, the value of the function again turns to become n. And again, if I see the function, it is also having the highest power of x as 1. Since the highest power of x is 1, it's again a linear function. So I draw a straight line again. So I get this straight line as well. Now, when I see this interval, I understand basically the function is increasing in this interval. So I get this. Now let's see the other interval. So for the other interval, if I talk about from 3 over 4n to 1 over n, I know the function is continuous, but let's also check it. So if I put 3 over 4n in this expression, I get x turning out to become this n and n cancels 1 minus 3/4. That is 1/4. 1/4 into 4, 4 and 4 cancels, you get n. So you still get this as n at 3 over 4n. And now if I put 1 over n, so if I put 1 over n, this n and n gets cancelled. So 1 minus 1, 0. 0 multiplied with anything always gives you 0. So you again get this function turning 0. And again, if I see the function, the highest power of x is still 1. So it's basically still a linear function. So I get a straight line again, but a decreasing function here. So for this interval, I understand the function is decreasing itself. And the last function, if I see, for 1 over n, if I again put here 1 over n, the lower limit, this n and n gets cancelled. So you are left with 1 minus 1, 0. Multiplied with anything doesn't make any sense. It will still turn 0. So you still get 0. So for the last interval and the lower limit of 1 over n, I get this is still 0. Now if I solve for the upper limit, that is 1 here. So if I'm putting x as 1, I get this is n minus 1. So entire n minus 1 gets cancelled with this n minus 1. And you're just left with n. So you get the upper limit here, and that basically turns to become. So you get for the last expression n over n minus 1 into nx minus 1. So I get for this that basically when this interval is there, the highest power of x is still 1. So it's a straight line. And for this interval, it's an increasing function. So I'm getting the entire idea of the function now for x equals to 0 till 1. And I understand in the first interval, it is decreasing. In the second interval, it is increasing. Then in the third interval, it is again decreasing. And the fourth interval, it is increasing. So now the question tells me that n is such that the area of the region which is bounded by the curves x equals to 0. So x equals to 0, if I draw it here, let's show all the lines with this purple mark. So x equals to 0. So if I show it by this purple mark, this is x equals to 0. This is x equals to 1. This is y equals to 0. And this is y equals to the function f of x. So basically the area between this entire thing, this entire area is given to us is equals to 4. So once this entire area is given to us is equals to 4, the question is asking us to figure out the maximum value of the function that I can have here for this expression. So if I want to find the value of n, I know here that maximum value of the function, you can see the value of y goes from 0 till n. So if I have been asked the maximum value of this function, I understand the maximum value of the function becomes equals to n. So I have to just figure out the value of n, and once I get the value of n, I get the answer for the question that is given to us. Now I can use this idea that they have told us area is equals to 4. So if I find the area of this entire triangles that I have here, so area, let's figure out that. Area total is basically nothing but sum of all the triangles that I have here. And the triangles, if I see half into base here is 1 over 2n, height is n. So you get half into 1 over 2n into n. plus the next area, if I see, it's half. Base is 1 over n minus 1 over 2n, and height is still n. And the last one, if I see, the base is 1 minus 1 over n, and the height is still n. So let's see what I get here. So if I solve for this n and n gets cancelled, you get 1 over 4. This, if I solve further, I get 2n minus n over 2n square into n, plus this becomes half n minus 1 over n into n. So this n gets cancelled, this n gets cancelled. Now further, if I solve, I get 1 over 4. This entire area is 4 plus half. This is n over 2n. This cancels, plus half n minus 1. So I get 4 is equals to 1 over 4 plus 1 over 4 plus half n minus 1. So further, if I try to solve it, I get this expression turning out to become 4 half plus half n minus 1. Half taken common, I get 1 plus n minus 1. 1 and minus 1 gets cancelled. So 4 and that 2 gets multiplied. So you get the value of n turning out to become 8. Now once I get the value of n turning out to become 8 here, that is the value for the question that is asked to us. Maximum value of the function f, and maximum value of the function, we understand it is nothing but the value of y, and the maximum value I get for the value of y is n, and that is basically equals to 8. So the correct answer for the question that is asked to us here becomes 8. So 8 becomes the correct answer here. I hope you have understood how to solve this type of questions which deals with the ideas of using the integrals. So here we didn't even need to use the integrals. We just found all the 4 functions in the intervals, and we found the maximum value of the function, which turns out to become the value of n, which in turn becomes the answer as 8. I hope you have understood how to solve this question. I'll see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on JEE Advanced. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well, and do subscribe to my channel and share this channel with your friends also who are involved in this preparation of the questions on JEE Advanced, so they can also take the benefit from these questions that we are solving on everyday basis. Thank you.